All right, folks, welcome to week 12. The last week with new content. Literally after today, there's nothing new coming in your direction. Today, I'm going to talk about views and how you use them. In level 2, you'll get a significant larger chunk of views, but it is what it is. I did get my timetable for the fall changed. I still have you guys, but only for half the semester now, just so you know. I get you guys for the second half. Cool beats. And the other thing I'm going to talk about today is, outside of the views, I'm going to talk about the final assessments. Number of questions, that kind of thing. Format. None of it should be a surprise, but just going to say what it is. Next week, attendance is optional, even though based on the number of people here today, it seems it's optional anyways. But if you have questions about the final assessment for the practical, I'll be here to, if you have questions with the practice test. And the week after that, I might just cancel the class and save you guys having to come in for me, because the content's done, the review's done. So, I might be here grading. But August 5th. Yes. Yippers at your usual time in the usual place. So I'm actually going to talk about that after I cover the rest of the material. Okay. Now to get into this week's material. I'm going to talk about views. A view is a stored query. My database prof I had in college would be very angry if he heard me explain it the way I'm about to explain it. A view is to a database as a bookmark is to a browser. So in your browser, you've got a bookmark, so you don't have to remember these big, long URLs. You just have, a nice short bookmark. A view is roughly the same idea. Essentially, you take a query and you will store it in the database so that you can reuse it with its own name. Most database servers only have one algorithm for views. MySQL, being what it is, has two different algorithms. One is a temp table and one is a merge. And there's also the choice of making it undefined. So the way temp table is slow. So the way temp table works is it takes a really complicated set of queries, takes the results, and puts them in a temporary table, and then returns results from the temporary table. The merge algorithm does it all in memory. Undefined means the query analyzer looks at the query that's been stored and determines the best engine to resolve it. So unless you have a really good reason to set the algorithm, never set it. Just accept whatever MySQL wants, which is why the hint is always stick to undefined, because that way let the database server figure it out. It's really rare that it gets it wrong when it tries to guess. All right, so to create a view, we're going to harken back to one of the first lectures we had, which was the create command. You might remember create table. Create view. Now, just like creating a table, you give it a name. In actual fact, I forgot to pick my schema. Hold on, I'm going to be using FlightDB for this, just so you guys know. So I'm going to call this one airport countries as. So this part of the command is you're telling the database server you're going to create a new view. It's going to be called airport countries. And then the as part tells it everything that follows after this is the actual SQL that we're going to run as the view. So I'm going to go select airport ID, comma, name, comma, countries dot name as country, from airports, join countries on countries.id is equal to airports.country ID, and it didn't grab my schema when I selected. Let's try that again. Oh, see, I came in unprepared today. I forgot to start my database service. One moment, it only takes me a second. Okay, let's try that one more time. Significantly better. Okay, so now we're connected to the flight DB, and I am going to create my view, and I'm going to run this. And it's airports.id. There we go. Well, let's try that again. It really does help if you type in all your things correctly. Now, just like when I was talking about joins, I left one of the column names ambiguous. The column name is ambiguous because both tables share it. So I'm going to just update this to be airports.name as airport. So I give it a proper name. And I'm going to rerun this query one more time. And now I got no errors. So now I've got a view that returns the airport ID, the name of the airport, and what country it's in. Now I can use it just like such. And I go select star from airport countries. This is the view I just created. So now I took this not super complicated chunk of SQL, but a bit of typing, and I gave it a nice short name. At this point, it looks like a table. It smells like a table. It behaves kind of like a table, but it's not a table. This is known as a dynamic view. A dynamic view, essentially, every time you call it, will run the embedded query every single time and query against the contents of the database in a live manner. So it's done right away. Now, with that having been said, it will use indexes from the underlying query. Any of the table optimizations that the underlying tables have behind the view are utilized. So it behaves the same performance as the existing query that's embedded in it. So you're not losing anything from creating views. So the next thing you might want to do is you might want to change the contents of a view. Because sometimes business needs change. You need to add something to a view, change how it behaves, maybe add some filters, all kinds of things. And depending on your database engine, although I put out this warning now, but it's getting less and less needed, some database engines, if you change the number of columns in the view, you actually have to drop the view and recreate it. I haven't tried with MySQL. This version of MySQL. Last time I taught this course, we were using MariaDB. MariaDB allowed you to recreate the view by changing the number of columns without any side effect. Postgres lets you recreate it with no side effects. If I remember at Oracle, you have to drop it. But I might be wrong about that. But so I'm going to retake my view. I'm just going to copy it because I'm lazy. I'm going to paste it, and I am going to add a where clause to it, where airports.name like B%. So I want just the airports that starts with B. And when you want to update the view, you change it to create or replace. So if the view doesn't exist, it creates it. If it already exists, it rewrites basically what the view does on the inside. So now I'm going to run it. And I'm going to run the query again just to show you guys that it did what it's supposed to do. And now you can see that it's been updated to only have airports that start with B. Now, here's what's really interesting about views. Once you've defined this view, you can use it just like a normal table. So for example, here I can go select routes.star from routes, join airport countries on routes dot, I don't know, destination airport ID is equal to airport countries dot ID. All right, so I'm going to run this query, and you can see that it's pulling in all the route information. I'm connecting to the view, not to the underlying tables. But now I could actually go where country is equal to Canada. And now this gives me all the routes for the airports with the country of Canada that basically start with B. Just to prove that I'm not lying, I'm going to go airport countries dot airport. Like this. Then you can see that here's the airport, the airline. Yeah, there's a bunch of there's all the different routes that land at each of these airports. So right now, this view is acting like a table. It's simplifying some of the underlying structure by connecting it to the country so that if you want to do a query later and you know you're going to want to use the country, you might not need to write all the pieces of the join. You could use the view instead. You can use views in a subquery if you wanted. So this one I just wrote right now, I am going to change this so select star from routes where destination airport ID in, and I'm going to go select star from airport countries where country is equal to Canada. And this has gotten very long. And I'm going to put a semicolon and run this one. And I got an error. Operand should contain, oh, there we go. So you can use the view in a subquery too. You can use the view wherever you'd have a table, you can use the view. I do have, oh, I lost my alternative example. Nice. I actually had another complete set of examples in here, and some unknown reason it didn't sync in OneDrive when I did it at home. Okay, so I'm going to create another view of the same nature. But this time I'm going to go airlines. And this will be airlines.id and airlines.name from airlines on airlines country ID. And then I'm going to go select star from airlines country ID and run the whole thing. And now I've done the exact same thing now. And I can pull the airlines operating country as part of the query. So views have a few different use now that you've seen them, the behavior of them. Not only can they be used to simplify queries, you can use them to simplify data transfers between servers, for example, because you could create a view that flattens the table structure in such a way that you can now take that data and ship it to a data warehouse. By flattening the table structure, that's known as denormalization. The opposite of normalization. You're going to learn about normalization next semester. If I remember, it'll be week 2. Just putting it out there. And So you can denormalize, transfer the data. You can also set up views to secure the data behind it. So for example, let's say there's certain columns that are sensitive and you don't want to allow people to see them. You can create views and grant permissions to those views only. And that would allow a person to be able to look at, do queries against the database, but not see the sensitive information. For example, you could actually have like social security numbers or credit card numbers or whatever stored somewhere in the database. And if the end user can only ever see, or even the developers can only ever see the views, then you can use that to hide the underlying table structure, the sensitive data from them. One other use I've seen for views in my career is table structure changes. We're adding fields, taking fields out, whatever. Usually adding fields or renaming fields because, the application's evolving, whatever, but there's applications out in the wild that have already been deployed and they expect a certain table structure to exist. You could create a view mimics the old table structure. So you rename the new table to something else. So like instead of users, you call it users 2 or, users 2 new or whatever. And then you create a view called users that has the existing table structure. And once all the clients in the wild have been updated, you can then flip the names of the objects and suddenly, or the versions out in the wild will now be talking to the new table. All the old ones are dead. And the view came to the rescue to save you from that. That's not as common now with web-based applications because with web-based applications, it's the deployment is to one server or just one cluster of servers. Everybody who accesses a web app gets the update in one go, right? Everybody gets it. So there's no delay. But back in the day when we used to have actual client desktop software where the application ran on the person's PC, sometimes we needed to change the database structure, but we couldn't always do it all at the same time. Go ahead.
I understand that for views, every time you create a view, you don't have really continues the data at the if you want to refresh it, you have to drop it.
No, that's a materialized view. Yeah, so there's two kinds of views. You're actually going to learn about them in level 2, but this is known as a dynamic view. All it does, all the view contains is the query, and it's live. The second you run the view, it looks at the live data. A materialized view is a view that when you run the query, it caches the data inside itself for performance. That's usually used in data warehousing. One of the projects I worked on, we had materialized view that calculated sales daily. So then they could run a report for a trend of sales over time, but instead of going through the database and calculating every order total, it was already summarized in a flat table that we could just then run queries against to report. With the materialized view, if it's in something like Postgres, there is actually a command to refresh the materialized view. It basically truncates it and repopulates it, but doesn't drop the structure. In old flavors of MySQL, and I'm not even sure if this version that we have installed for this course supports it. I'm pretty sure that MySQL 8.3 and one of the more recent versions of MariaDB now support materialized views. But if you're working with an older version, it doesn't support it. So how do you handle a view in the old structure? You create a table for the materialized view, and instead of doing a refresh command, you're literally going to be doing a truncate and then an insert into from the query that would generate it. There's a lot more code involved. There's more things that you have to take into account. Often what happens is people will write a stored procedure so that they don't need to remember the query, and they just call the stored procedure and it refreshes the materialized views. Air quotes around materialized views because really they're just tables. The only thing about materialized views is they tend to be slightly more performant than tables. It uses a different caching algorithm, so it tends to be a little quicker. than a table, unless the table is highly indexed. But if you are truncating the table, you have to actually drop all the indexes before you load it and then recreate the indexes. So in the end, there's no big gain in either direction. Honestly, they're more or less the same thing. It's just how you handle keeping the data fresh is different. The good news is these are dynamic views. They do not store the data because it queries the underlying database right away instantly. It's live, thus it's dynamic because it's always up to date. Materialized means it was physically turned into something that's material. Star Trek teleporter, they materialize, they become a solid object. Materialized view solidifies the data, the contents of the query. Is that a good answer? Okay. All right. So that covers the topic of views for this course. Next semester, they're going to talk about views with slides and explaining how views actually decompile and recompile when they're doing joins and stuff like that. So it's a significantly more in-depth part of the lecture. So now I'm going to switch to talking about the exams. And in my typical, super fancy way of doing this stuff, I've got a notepad with the stuff on it. I'll be posting this to Brightspace, so you don't need to. Every semester, I always have students that try to take pictures of the screen when I'm putting this stuff up, and I'm like, I'm going to post it. If you don't know it's on Brightspace, that means you just don't go to Brightspace very much. All right, so start with the practical assessment because that's the first one coming up. August 5th at 4 p.m. in T111, also known as your lab period. There's a practice test up, and it's available. Before you try to do the practical test, or before you try to do the actual test, there's a new database you have to bring in. It's called Algonquify. Depending on the speed of your laptop, it'll take anywhere from 30, 40 seconds to 5 minutes to import, assuming nothing goes wrong. I ran the import on MySQL and it worked just fine. Originally it was designed for MariaDB, but I just changed the metadata version on it and it worked just fine with the version of MySQL I'm running, which is actually older than the one you guys are running. Now, I'm just going to pop over to Brightspace really quick. Maybe. There we go. Here. And in the course content, you'll see down the left, final practical assessment. There's some instructions on importing it. There's the zip file. You want to download it and extract it before you try to import it because none of the database software knows how to import a zip. Here's the practice exam, some useful functions. MySQL has the exact same ones. Eventually, the exam itself will show up in time for everybody. And then, so the practice exam, it's 7 questions. Wow, the writing is small. Let's make it bigger. It's 7 questions. It touches Algonquify, Sakila, and the World Database. So it touches 3 databases. I do ask with your solution that you please include your use statements. Makes it a lot easier when I'm writing your code that you're switching, as you switch the database in your code, it switches it for me too, so that I'm not like, oh, I got an error, now I got to go type this in. Not that it adds a lot of time to my grading, but it's just annoying. Just don't annoy the prof. It's just a good thing. So again, it's 7 questions. It's 1 hour, 50 minutes long, so 2 hours long essentially. 1 hour, 50 minutes. You're allowed slides, notes, and labs. You can Google. You can't ask AI. And by the way, the Algonquify database is so big that if you try to feed it to one of the AIs, it just rejects the file. It's like 56, 60 megabytes. The AIs don't like it when you try to feed them a big file like that. Just saying. So the AI won't be able to help you for the Algonquify questions, and considering it's 4 of the 7 questions, should figure that out. So like I said, make sure you import Algonquify so that it's you have a chance to look at it, to understand the data in it. Again, you'll submit an SQL file with question number, answer. Same thing as the other midterm. All right, now the theory exam. The theory exam is August 13th at 4 p.m. For those that don't understand, don't understand the AM PM, that's 1,600 hours. It's going to be in A1304. I'm going to pull up the map in a second. It's 1.5 hours long, with 35 questions. Like, definitely shouldn't need an hour and a half for 35 questions. It should be done on Scantron. Unless I can't find Scantron sheets, it should be done on Scantron. It's just the test center closes at 4 o'clock, I think, and all my classes start at 4, so it's a little hard to go grab Scantron sheets. But anyways, and the usual, no aids, no devices, bags go on the floor, put your shit away kind of thing, the usual. You're allowed drinks within reason. Okay, now what's the breakdown? So the exam is not, I wish I could say that the final exam is only on what's in the second half, but it's really hard to make it only on the second half. So the majority of the questions have to do with the second half, but there'll be a few questions from the first half. Where clause, 8 questions. Like, there's 5 questions. Sorting, there's 2. There are different questions on the first time. It's just me double checking. The thing is that if you've done all the labs so far, those questions are gimmies. 2 questions about DDL. 4 questions about column selection. Now, we have 8 questions about aggregates, group bys, and halvings. 2 questions about views. 5 questions about subqueries and joins. The subquery and join questions basically have to do with what's the syntax. You're given a chunk of SQL. Basically, it says, what is this doing? Left join versus right join, that kind of stuff. It's asking you questions about what they do. Basically, do you understand what it's going to do? The practical assessment actually proves to me you actually know what it does because you're using them. Okay. Now, that having been said, are there any questions about anything I talked about today? Going once, going twice. I can hear the crickets down the hall. See here. And okay. All right, that's it. That was the last bit of content for the semester, so we're basically done. Like I said, next week I'll be present to help anybody who's having problems setting up Algonquify, anybody who is wanting to have assistance with any of the questions because they don't understand what the questions are asking. If you want to practice the practical assessment while there's a teacher available to do it, that's what I'm here for next week. The week after, I'll send an announcement depending on what shakes out. And